Ladies and gentlemen, I'm Pourya from Iran, and the topic of my presentation is...
Pourya, please wait. Can I ask Palestine? Can you go and control for him?
Okay, Palestine, come.
Yeah, go control for him. You don't need to pay 9 ringgit. Go control for him. All right.
Okay, and the topic of my presentation is hybrid neural network table search method application to single machine scheduling problems with earliness and tardiness penalty. Okay. The problem of scheduling of n jobs on one machine that all jobs have common due date is considered. The scheduling objective is to find a proper sequence to minimize the sum of the job depend earliness and tardiness penalty around common due date. In this project, we use two algorithms. The first algorithm is neural network, and the second algorithm is table search. Okay, the first one, I wanted to say that what should we do in this project. As you see, the companies that produce some materials want to produce the material with these two items. These two items is very important for them, time and cost. And all of them want to produce the material with the minimum time and minimum cost. Now in this project, we suggested the ways that if the companies use these algorithms for the producing, the line of producing, they can produce the materials with the minimum of time and minimum of cost. For this way, we use these two algorithms, neural network algorithm and table search algorithm. These two algorithms both of them are very powerful in minimum the cost and time. So, as we know, the table search algorithm is very powerful than neural network. What we do in this project, we take some sequence of jobs for the input of neural network, and after the processing of the input, the neural network give me the output. And after that, we get this output for the input of table search algorithm, and we get output of table search. And this output is our aim in this project. So, as you see, as I told you, both of these algorithms are very powerful in the minimum of the cost and time. So, when we give the sequence of jobs for the input of neural network is powerful. So the output of this algorithm is very near to our aim. After that, we get this output for the input of this algorithm. Table search is more powerful than neural network. So the input of this algorithm is very powerful. The algorithm is powerful. So we attempt a very good answer. I mean, the very good output to near to our aim. That in the end of this presentation, we can see the results. Okay, we have in this slide we have some. We introduce some of the characters that we use. For example, S is a schedule for n jobs. Pi the processing time required by job I on the machine. D is the common due date, and these two items, AI and BI, AI is penalty per unit time for the earliness of job I, and BI penalty per unit time for the tardiness of job I. And the formula that we use for the calculate the penalty is AI times EI plus BI times TI. That in the next slide, I show you these items with the numerical example. Okay, table search. Table search algorithm. For example, I wanted to show you the table search method. I mean the algorithm of table search with the example. For example, you see that you have 4 jobs. 1, 2, 3, 4. And this is the sequence of 4 jobs that it should be do it in some factory. Table search algorithm say that the first one, you should be calculate the penalty of this sequence of jobs. after that, you should be specify and determine the subsequences of this original sequence and calculate the penalty for the subsequences. After that, compare the penalty of subsequence with original sequence and do something that you can see it. For the again the subsequences, there is one rule. The rule is taboo search tell us if you want to get the subsequence from the original sequence, you should be only change the jobs that are beside each other. For example, for these 4 jobs, we have 3 subsequences. The first one is they change these two jobs. I mean the first sequence is 2, 3, 1, 4. This is the first subsequence. The second one, we should be change these 2 jobs. 3, 1, 2, 4. And the last one is 3, 2, 4, 1. So for this original sequence, we have these 3 subsequences.